Morning students, how are you? I am Francis sir, and today we will be studying standard 7 physics. Today's topic is a very interesting topic. You did study this in standard 6, okay, and the chapter's name is motion and time. So when we are to study this chapter, you might have come across this term motion. What is motion? Whenever a body moves, you can say that the body is in motion. But how do we define motion? Means what is the way we could define motion? So motion could be defined in a way that when a body changes its position, change in a position or location of a body with change in time. That means when a body changes its position or location with the change in time, then it is said to be in motion. For instance, if at 1 p.m. a body was at Buddha. A body was at Buddha. And what happened at 3 p.m. At 3 p.m. the person is at position P, and that position is your what? Devgar. So you understand the position or the location of the body has changed from Buddha to Devgar with the change in time. So we can say that the body was moving from Buddha to Devgar. So the body was in motion. The body was in motion. Okay? But if at 1 p.m. the body was at A, body A was at where? At Buddha only. Same place. At 5 minutes also it was here, 10 minutes also it was here in Buddha, 3 minutes also it was here in this place only. Means it did not move from this place. It did not move from this place. So in this case we see that the body is at rest. So there are two types of conditions, motion and rest. Motion happens when the body changes its position with the change in time, whereas rest happens when a body remains in the same position or location, with the change in time. The time is changing but its position is not changing, so that time it can be said to as rest. So but we are talking about motion, so you understand the motion is, when do we say motion? We say motion when a body changes its position or location with the change in time. Okay? Okay. Now we will be talking about types of motion. The first type of motion is your translational motion. Translational motion is a type of motion in which a particle moves in such a way that all its particles are covering equal distances in the same interval of time. Means, for example, we have this linear motion. Then we have curvilinear motion. Then we have random motion. All these three are the examples of your translatory motion. So one very good example is you take this point and let us take this chalk. Okay, you see the starting point of the chalk. It has to move from this place to here. This point has to cross this line. So for crossing the line, what it has to do? It has to move from this place to this place. So let's find out the displacement. Okay. So this was the initial position of end point, and this was the initial position of the starting point. So when this chalk crossed it, you see that the starting point has reached here and the end point has reached here. So you see the starting point has travelled how much distance? This much distance. Whereas the end point has travelled this much distance. You see the end point was here and now it reached here. You see? And the starting point was here and then it reached here. So what is the distance travelled by the end point? End point travelled this much, and the starting point travel this much. So you see that each part of the body, each particle have covered, you see equal distance, you see equal distance, end point from this length of the chalk and this starting point also length of the chalk or the distance traveled. So this is what happens. In translated motion, each particle, whether it be the first particle or the last particle or the middle particle, you know, all of them cover equal distance. All of them cover equal distance. Okay. Okay. But the only thing is, what is the difference between linear, curvilinear, and random? That in linear, the motion is in a straight line. In curvilinear, the motion is about the curve, means about the center. You know, there is a center imaginary and it gives a turn around it. So this is your curvilinear. And then we have random motion, a type of motion in which the direction of motion keeps on changing. Okay, for example, this is the example of a bee. This is the example of a bee, you know. A bee just moves here and there, you know, it takes around. So this is the example of random motion. Or you can say, tell the motion of a footballer. Footballer, no, it moves here and there, you know, you can't understand, you don't know which way the player is going to move. Yes, sometimes move right, sometimes move left, sometimes front, sometimes back. So the movement of a footballer also can be termed to as a random motion. Means they are translated motions, but the thing is that since their direction is not a constant, they are said to be as random motion. Okay, in random motion the direction keeps on changing. What keeps on changing? Direction. Whereas in curvilinear motion, the motion is about a center, imaginary center, you know, a curved path is traveling. Whereas in linear motion, the traveling is in a straight line. The movement is in a straight line. Okay. The second one is rotatory motion. The type of motion, you know, in which a body moves about its own axis. For example, let us say that this is a chalk, it has an imaginary center here, okay? So if it starts to move in this way, about the center, you know, its center is at the same place, but its ends, you see this end here, this end is at the top, now you see it is here, then it is down, and you see that its end points are moving, but the center point is at the same place. So this center point is the axis, this center point is the axis. So when a body moves about its axis, it is called rotation. What it is called? Rotation. Okay. So like Earth, you know, Earth also revolves around its axis. So when it revolves around its, rotates about its axis, we call it rotation. So you might have seen a top. You might have seen what? A top, no? You might have seen a top. It revolves, yes, it rotates about this pin, or you can have this coin thing, you know, you might have seen about coins. Yes, I got a coin, you know, I will show you. Yes, so you see this coin, this is a very good example. So if I catch it in this way, this top and middle and this top and first corner are joined together by an imaginary line called axis, and you see that it can rotate. You can see that it can rotate. Yes, so this is called rotation. When a body moves about a central line which passes through the center, you see these two fingers, you know, are just in the direction, you know, in perpendicular direction from the center, and you know this coin is moving around it. This coin is moving all around it. So this is called rotation. You can see this, if you could see, you know, if you could see this coin, you know, in the video, you know, you can see that, you can try it at home also. You will see an imaginary line, not imaginary means a line is there when it moves, the coin moves. You could see. I hope you can try this at home. You can try this at home, okay? So this is your rotation. This is your rotation. The movement of a body about its own center, it is called rotation. It is called rotation. Okay. Now we have rolling. Rolling is, you know, again we have a coin. Yes. So you can see this movement of the coin can be said to as what? rolling. Okay, so what is rolling? Rolling is a movement in which we have a circular object like wheel or the point that I showed you now, and it moves about its center. Yes, which is called rotation. But you know that when it performs rotation, this wheel also moves in the forward direction. Means it is showing a translatory motion. So this rolling motion is a mixture of two motions. One is the rotatory motion, number one, and second one is the translatory motion. So this is the mix of both. So we can see rotatory motion, this one you can see that it is rolling. Yes, I hope you could see. You are very much played with this type of things, you know this. So rolling, it rotates, and also what happens is that it moves in a straight line. Yes, I hope you could see this one. Yes, you could see this, this one. I hope you have seen this. So this is called your rotation. Rolling shows rotation as well as translatory. Both the thing happens. Now we have what? Periodic motion. Periodic motion is the motion which repeats itself after regular interval of time. For example, rotation of Earth is a periodic motion. Why? Because we face the sun every 24 hours. We come back to the same position every 24 hours. So we face, after every 12 hours, night comes. After that 12 hours, day comes, morning comes. So this rotation of the Earth is a periodic motion. Then the revolution of Earth is also a periodic motion, because after 1 year we come back to the same season, and same season comes when we come back to the same position. Same position can only be obtained, or we can experience the same weather or same season only when we are back to the same position. This happens after revolution. So revolution of Earth is also a periodic motion. Or we can say this pendulum. We have a pendulum. This is a pendulum. This pendulum, after moving from this position to this position, back to this position, it again comes back to the same position. So it comes back to the same position after regular interval of time. So this is called periodic motion. So the motion which repeats itself after regular interval of time, it is called what? It is called periodic motion. Okay. Then we have oscillatory motion. Oscillatory motion is the type of motion in which objects moves to and fro about a mean position. For example, if this is the mean position, my finger is the mean position on this chart, it will move like this, then it will move. So you can see that the object is moving to and fro, कभी दाएं कभी बाएं, about the mean position. Mean position मतलब एक fixed position होता है, उसके about ये move करेगा इस तरीके से. So this type of motion can also be seen in what? Pendulum. So it moves about the mean position to and fro motion, दाएं बाएं, right and left. So it moves about the mean position. Okay, so this type of motion is called oscillatory motion. The to and fro motion of a particle about the mean position is called oscillatory motion. Now we have vibratory motion. Vibratory motion is same as oscillatory motion. Only thing is that vibratory motion is rapid. Rapid, very fast. Rapid means very fast. So it is the rapid to and fro motion about the mean position. Rapid to and fro motion about the mean position. This is called our vibratory motion. So these are the different types of motion, and this is motion. So I hope this is enough for today. This is the introductory lecture for lesson number 13, and quite of this you have experienced in your daily life also. Yes, so try to relate it with your daily life and also study. So with this I end my video. See you in the next one. Okay, good day.